In the previous video we went through what momentum was. Now we're going to do conservation of momentum. In a closed system, momentum is always conserved. That means momentum before equals momentum after. This is higher tier only. Combined students, you need to be able to describe collisions and describe momentum in events, and physics students, that's triple students, you need to be able to do the calculations. Okay, so momentum before equals momentum after. Momentum before equals momentum after. So if something's stationary, it's got momentum before of 0, so it must have a momentum after of 0. What about if a snooker ball is colliding with another snooker ball? So let's say we've got a snooker ball of 2 kilos, it's a very heavy snooker ball, and it's travelling at 13 meters per second. 2 times 13 is 26, so we've got 26 kilograms per meter per second beforehand. So afterwards we must have 26 kilograms per meters per second after. So let's look at that snooker ball and let's look at a situation where it collides with another ball. So let's say that ball goes and collides with this other ball. This ball goes off and travels at 10 meters per second. So this ball has 2 times 10, which is 20 kilograms per meter second. It's got a momentum of 20, but the momentum after must equal 26. So what happened to that missing 6 kilograms per meter per second? What happened to it? Well, we've only considered this ball after the collision. That initial ball, that initial white ball, after would be moving just at a slower speed, at a lower velocity. Instead of going at 30 meters per second now, it must have a total momentum of 6, so 6 kilograms per meters per second. The mass is still the same at 2 kilos. What is the velocity? Opposite of times 2 is divide 2, so 6 divided by 2. 6 divided by 2 equals a velocity of 3 meters per second. Physics students, you need to be able to show these calculations, and combined students, you need to be able to describe it. So if I was to describe this collision, the first ball is colliding with this stationary ball, so the total momentum before was a value, let's say 26, and the first ball is going to slow down because it's transferred speed. So it's got to transfer the speed because it's transferred momentum, because momentum before is momentum after, the conservation of momentum. If one object is speeding up, the other object has got to slow down to conserve momentum. What about momentum in a stationary situation to start with? When we talked about Newton's second law, we looked at a boat situation where a man jumped off forwards and the boat moved backwards. So let's have a look at that in terms of momentum. So there's a boat and a man or a woman or just a general person on the boat. The person has a mass of 70 kilos. The boat has a mass of 200 kilos. And in this initial scenario, they are not moving, so the momentum is 0. So momentum before equals 0 kilograms per meters per second. So the momentum after has to equal 0 kilograms per meters per second too. So if the person 70 kilos jumps forward at 3 meters per second, they have a momentum to the left of 3 times 70. So person momentum equals 3 times 70, which equals 210 kilograms meters per second. So if the person's got momentum of 210, the boat must have a momentum of 210. So the boat momentum equals 210 kilograms meters per second. Because we've got the boat momentum and we know the mass of the boat, we can calculate the velocity of the boat. So the momentum is 210, and that's equal to the mass, which is 200 times by the velocity. We don't know the velocity, but we do know the opposite times 200 divided by 200. So 210 divided by 200 is the velocity. Trusty calculator time, 1.05. So triples, you need to be able to do the calculations. Combined, you need to be able to describe this conservation momentum. This type of momentum is called an explosion, where one object moves one way, the other object moves the other direction. And if we were to describe this, the person is lighter, so they're going to move faster, whereas the heavier object is going to move more slowly because it's got greater mass, because the momentum has got to be equal. Whatever momentum is going left, the momentum right has got to be equal to as well. Another way you could look at this is we've got momentum of the person is minus 210 kilograms per meters per second, because it's going to the left. If left is negative, then right must be positive, which is what the boat is, so plus 210 kilograms meters per second. But at GCSE level, you do not need to use the signs.